Okay, so let's talk about module 17, talking about building a small network. Now, which lab was it you were wanting?
There is 17.46.
17.46. Okay. So okay. So
It was not much to it, but they put us on the second line after the background checking. They said that check with your instructor for any local security restriction against using the ping.
Right, right. And that's where I told you about it. Maybe that you are not able to actually do pings because they're being blocked on your local network. More than likely, you will not be able to ping outside of your local campus network because of the fact that it's just, they don't allow that. Let's see, 17. Yeah, see, we don't, that lab is not available as a NetLabs lab. If you do this lab, what's going to happen more than likely, because you got your PC, if you try to do these, what's going to happen is you'll see it resolved to an IP address, but you will not see the pings take place. So let me show you on my example here. So if I go to my network, and so we're right here, let me pull this over so that I got this over here. So let's go here. So if I type ping www.lacknick.net, it'll resolve to, so DNS is working, but it is going to fail because we block ping on this network. So this lab about 99% of the time does not work if you do it from work. Now, if you try this lab at your house, it will probably work.
Okay.
Okay. So I would suggest if you want to do this lab, do it at your home,
Okay.
not at your work, because your work is going to block these pings. Still, honestly, a lot of these pings are going to probably fail because of the fact that you hit a site that blocks ping. But it's still worth, it's worth trying it from home. But that's where they're talking about, where they say, if it will fail. More than likely, if you try to do this lab with your students and your campus network, it's not going to work either, because your campus network is blocking pings. They will not allow pings to go from inside out. So, and rightfully so, or outside in, even probably bigger, because of the security problems that could take place with these. So that's what they're trying to get you to really look at there, is just how that could cause or what that's trying to do. And I think, where's that at, where it says if there's a, yeah, but that's why it would not work for you.
Okay, along the same way again, because I was trying to ping that org, and it doesn't go through.
Right.
Or when I use the .com, is there any reason why it doesn't go through the .org?
It's not going to work for any of them because ping is being blocked. So what happens is the ping is going out. So, ping is just an ICMP echo request. Okay. So if I go in here right now, so let me start up Wireshark on my machine. So I'm going to start Wireshark on my PC. Okay. And I'm going to find, as soon as it gets my local interfaces here. All right. So we'll do remind me later. All right, so we're going to collect, let's see, the loopback's got a heartback, so heartbeat. My Ethernet connection's got a heartbeat, so I picked that one. So we're going to go here and start. We're now grabbing information, okay? So I'm going to go over here and I'm going to try to ping LACNIC. All right, now what's going to be interesting is if I go over here now, you see it timed out. It's going to time out multiple times here. Should go 4 times and time out, and then finally just fail. All right, I'm gonna go back over here to Wireshark, and I'm going to stop. I'm gonna put in a filter of ICMP, which is Internet Control Message Protocol, and you'll notice I sent an echo request, and you'll see that it had a time to live exceeded. So in other words, it got no response. So I sent an echo request, but there's no reply coming in here. Regardless of who I ping, whether or not I ping lacknick.net or I ping www.novell.com, okay, Let me start this back up. I'm gonna start a new capture. Start. Okay, so let's go back again, and it's ping novell.com. It's still going to send out. See, there was my echo request. You'll notice it's going to time out, but these echo requests are going out. No echo replies coming back. But watch what happens when I do this. If I ping my default gateway, all right, so let's ping my default gateway. So, and I'm on the 10.0 network. So I do an IP config just to show you that. I'm on the 10.102.10 network. So if I ping 10.102.10.1, you'll see I get an echo request and an echo reply. So there's really no difference between a .com, .edu, whatever. When you send a ping, it sends an ICMP echo request. So this ICMP protocol, you get this is a request. If the device you're connecting to can respond, you'll get back a reply. So this is my gateway replying to me. But all these others are failing because we have a security policy that does not allow ICMP, the protocol, to leave our network and come back. So it doesn't matter what you ping in terms of, novell.com or lacnic.net or any of that. It does not matter what this is. It's sending to this IP address. Okay. In fact, you'll see what's happening here. You'll see how it doesn't even care that it's lacnic.net. It resolved it to 200.3.14.184. So my machine sent an echo request to lacnic.net or 200.3.14.184, but it cannot respond. And so it times out because our network is blocking that request going out. So does that make sense?
Yeah, it makes sense. Like I said, I was trying it on my laptop, then with Wi-Fi linked, and I get some. Since then, I tried it with a desktop PC to ping the ORG and set timeout, and after sometimes then I come back and ping the same address with the .com, and I start to be getting some things I do not know what what make it not to go in the first place, and then
right. Well, what it is that there's a rule on the firewall for the network that is blocking ICMP. Basically, there you can set it up to say, do not allow anything that is ICMP to go in or out of my network. And so it's just the firewall has been set up to block those echo requests and echo replies. And that is for security reasons. That's just because we do not allow ICMP to leave our networks and come back in. Now, hopefully, as we move forward and we get to IPv6, we will enable full end-to-end connectivity. And then it'll make life a whole lot easier on us, because then we can actually ping to a host and have full connectivity. Okay. Any other questions?
Well, on the same chapter where you have, if you go up on that chapter, I think it's 17, one or small, where they give like the scheme for the let's see what designing on that page. I think it's 17. I think it's before that one.
Yeah, there's nothing. This is the very first mod page here.
Yes, okay.
Let's see. I can move forward.
Okay, that area there. That's area.
Okay. So what they're talking about here is what we talked about back in our section on IP subnetting and addressing. You'll notice what they've done here is they broke individual. This is probably the different floors of a building. So you've got 3 floors in the building, and they use 3 separate subnets with 3 separate networks. 192.168.1.0/24 for one floor, the second floor, and the third floor, and then they use those ranges. Now you'll notice here they've actually used This is called summarization, and this is a little different. But what they're trying to show is that they want a way to consistently organize the networks so that they can summarize them to a smaller portion. So for this, what they're trying to do is to say they're going to break it into multiple other VLANs or other networks using different masks. So basically, they're going to use VLSM to try to do this. Now, I will tell you, the way they're doing this summarization here, that is crazy. To try to make it to where you're breaking each one of these down is insane. I mean, I would just say that you've got these individual networks on each one of these floors. If you're trying to summarize down to this level, you've got problems. And to be quite honest, your wireless clients are probably all going to be on their own VLAN. They're not going to be part of the VLAN of a floor. So where they've got these wireless clients showing here, in the real world, we just have a wireless VLAN that is spread across all the floors. And we can do that because of what's called tunneling. We can do it with tunneling in our wireless networks. So what they're just showing here is that they took this major network, the 192.168.1.0, and they decided what parts of it will be used for what. So in other words, I said the first two addresses could be used for a router. The next two addresses will be for switches. The next 6 will be access points. The next 6 will be servers. For what we would normally do instead of all this crazy summarization is we would just say that everything less than 30 is going to be a networking device. Anything above 30 is some kind of host. And that would be a way we would do it. This honestly is not a good way to build a network.
Okay.
This is not how I would do it.
Okay.
I don't mind having different subnets per floor, but as far as the wireless goes, the wireless needs to be over on its own VLAN, completely separate from each network, so that you don't have to worry about that wireless traffic being on your wired network VLAN. So this is just an example of a way you could do it, but it is not a best practice, I don't think, in any way, shape, or form.
I was, when I look at it, I said, well, I don't think that you, because it seems like the figure that they have where they have different subnet, that's what they are.
Yeah, you would never, and really what they're not saying here, they're not saying to actually subnet it again, although you could. What they're really just saying is this is the part of that subnet dedicated to this function. So all they're really trying to say here is that the first 2 IP addresses should be used for routers. The next 2 should be used for your switches. So put them on your switch virtual interfaces. The next 6 could go on access points or on access points. But this is a very poor way of showing that. They should have just said that instead of use this crazy table. So I would not, don't let this table confuse you. But the point is this: when you have a subnet or a network, you're going to pull out pieces of it and say addresses 1 through 30 are being reserved for networking devices and servers. Addresses 31 through 254, we'll use those for hosts. And that's all they're really trying to say here, but they just had to say it in a very convoluted, crazy way. So does that make sense?
Yeah, it makes sense because, like I said, I was just looking for the clarity on it, and they already have another method of doing it. And then, but in the beginning of this chapter, they said that this is how you can design the network of a small network, and then talk about that one. And I was looking at it that, okay, if this is a method that somebody can use to design for the small network work area. And that's why I was asking you the method that they use in that chapter.
Here's what I would do. All right, let's say we've got the network 192.168.1.0, and we're designing a small office. A great example, my wife's business. She's got about 8 to 10 computers. So here's what I would do. I would assign 192.168.1.1/24 That would be my my default gateway or my router interface. Okay, so that's going to be the IP address on my gateway. I would then put probably 192.168.1.1, 1.2 and up to, let's say, .6/24. And that would be for /24/24. That would be for any switches. So if I had any switches in the network, I'd have to put that on their switch virtual interface so they're manageable. Then I would take 192.168.1.7 through. Knowing how small her business is, they're not going to have that many servers, but just in case, I actually did this. I reserved 7 through 30/24 for servers or anything that needs a static IP. Okay, so if you need a static IP address, so like servers, you know, they need static IP addresses. They don't need DHCP. Then for DHCP for the clients, take 192.168.31 through say 80/24. And that'll be for the DHCP for all the clients that connect. And then you've got 81 through 254 that are left over to do whatever you want to do or whatever you need to do with them.
Okay.
Now, I don't have any wireless in this. Okay, so if I was going to have wireless, I would actually just pull another network. I would say 192.168.2.0/24, and I would create a whole new network for wireless. All right, that way the wireless is separate from my wired. And that lets you track clients. It lets you do security policies so that you can say that the wireless network cannot access the wired network or vice versa, so that you can have guest networks and you can have the ability of people get on the wireless network but not get to the server, so you don't have to worry about them trying to hack in your servers. So this is how I would do a small modern day network that I was designing.
That makes sense. So,
you know, the default gateway, these are still static IP addresses because they are statically assigned on the interfaces. You know, that's a static address there. This is a static address that we put onto the switch virtual interface. So, you know, really, you sit down and you talk about looking at what we've got, we could very easily, let me pull this over and just make it a quick example here. So we've got this, let's imagine we're building this network here. So we went and bought us a 4331 that's going to be connected to the internet. We got a switch. And so we just connect these two. I got to go and connect them first. So it's still booting, so let it boot. So we'll just do a standard cable. We'll do our gigabit. Yep, not that. I messed up. Needs to be on the gig 001 to gigabit 01. All right. So this switch is booting up. So I do no enable config T host R1 interface G001 IP. Whoops, I can't type. IP address 192.168.1.1 255.255.255.0. No shut. And then of course I would do all my other configuration tasks, such as setting my passwords, banner message of the day, all of those different things that we would normally do. Save that config, and then I go over to the switch. And we do int VLAN1 IP add 192.168.1.2.255.0. And then now we basically do a do write, and of course I would do my entire configuration on the switch. But at this point, we could set up a DHCP server, we could put it on the network, and we could have it start handing out IP addresses to our end devices, to our PCs that are connected to the switch. So, you know, these are static IP addresses that we are assigning to the PC or to the router and the switch. We're just putting them onto interfaces instead of onto a network interface card. So if I do a show int VLAN1, you'll see it's got a static IP address of 1.2, and I should be able to ping from here to 1.1. It'll fail, then it'll be good there. So we really just implemented really quickly this basic little networking scheme on a simplified network on our setup. Now I will show you something really cool here. You actually do have the ability in Packet Tracer, if you want to fully build out, watch this, you actually can go in here and put in a server, and that server can even do DHCP. So you can give it a name, so you can do a pool name. You can do the start IP address. So I know this is 192.168 or 192.168.1. We said we will use 31 through 80. Okay, so we'll do 255, 255, 255. Maximum number of users, we'll just do 30. Actually, we'll do 50 because that'll get us through the 80. We're going to turn it on. Right, let's do a default gateway. 2.168.1.1. We won't have a DNS server right now. We'll just put it 8888. Turn the service on. We should actually be able to go to this PC, and if it's on, yep, it's on, put DHCP here and automatic. We should actually be able to go to a command prompt, an IP config, and see that we get a dynamic IP address eventually. So renew. As long as I set that server up right. Nope. I see what I've done. Oh, I know what's wrong. I'm an absolute doofus. Let me put an IP address on the server. So we got to put a static IP address of 192.168.1.10. I'll give it 192.168.1.1. There's no way it's going to get an IP address from a server that doesn't have connectivity. So now let's try this. And you'll see it got 1.3. So I did something wrong with the DHCP server. So let me go back to my services. Maximum. That should have been right. Oh, I forgot to save it. Okay. Let's do a release and renew. We should get 31. Yep, there we go.
Yeah.
So that is one of the neat things you can do with Packet Tracer. I mean, we just built a little simple network right there. And now we're even showing DHCP. We're showing, and then you can even go here now and you could go into simulation mode and you could do a ping. So you could actually do a ping from here to here, and you can watch that ping go through, as it goes through the entire process. Actually watch it go forward. So you can go, there's an ARP request because it's not in the ARP table. So the first thing happens, an ARP request goes out, an ARP reply comes back from the server, and then the ICMP echo request is sent. See, there's the ICMP echo request going to the server. There it is, the ICMP echo reply coming back. So there's some really neat capabilities built into Packet Tracer. But it's still a simulation. That's the only thing I like to make sure people know. It's still a simulation, so we have to make sure that students have access to real gear also. Does that help?
Yeah, it does help. Yes.
Sure.
You show me more tricks now.
Good.
Because I was going on the different, I was going by the book, but what you advise me now, give me the another way. And then the way that you show me now, I have more new way. Like I said, you just have to watch the experts doing it, because it's not that you do one, that you know everything.
No.
It's something that you have to practice every day.
Every single
try
day.
it and
I
see
still,
what you have.
yeah, I forget stuff, and there's stuff. It's like I told you at the beginning of class. If anybody ever comes to you and says, I know everything about networking, and get run from them as fast as you can, because they have no clue. It's every single day I learn something new, and the field's changing so fast, which is what I think is really a fun thing about being in the field, is there's so much new stuff coming out every year that we get to really kind of, we get to have some fun with it. So I'm gonna stop my recording.